Our objective for today, I can add and subtract polynomials. Read together. 1, 2, 3. I can add and subtract polynomials. Tell your neighbor the concept we're still on. I can polynomials. Yes, polynomials is the concept. That's why we don't need a Ferrier model, right? By now everybody knows the definition of polynomials? Good. The question, essential question, what happens to the exponents on a variable of like terms? Elaborate. We'll get to that in a little bit. So, polynomials. Definition, let's think. Definition for polynomials is, polynomials are, tell your neighbor. Very good. Monomials or sum or difference of monomials. Okay, so we got this, right? We do need steps, though. Copy these down, please. It's only 4 steps. Step 1, distribute, which means multiply, the factors to each term inside the parentheses. Step 2, identify like terms. Step 3, use commutative and associative properties. Do we know how to use those already? Yes, Mr. Q. But now we're going to use them to combine like terms, which means for addition and subtraction. Previously, we used them for multiplication. And at the end, we're going to simplify. Copy that, please. Okay. So, step 1, distribute. Everybody knows how to do that, right? Step 2, identify like terms. I'm going to show you that again this year. Some of you already visited this last year, so this should be kind of like a review. But if it's not, hopefully we can clarify some stuff. And step 3, associative and commutative property, you can use that and simplify. All right, so check this out. Every year I introduce adding or combining polynomials in a different way. So hopefully this makes sense. It made sense to me. And like I said, everywhere I go, I usually see math. I don't know why. I'm just weird like that. So check this out. So, one thing I thought about is, what if I wanted to open up a store and all of you were going to be my peons for the store, right? My workers, the workers. Peons. So you guys are going to be the workers for the store, but I'm only going to make 2 of you supervisors. The rest of them are going to be, I got this, hold on. So watch. So the store, my store looks like this. Here he goes. So, it's going to be a...
I love pets.
So...
Oh my God!
Okay. So, we're going to call...
It was really hard to find that.
Yeah, we're going to call it Mr. Q's Pet Shop. It's going to be on 23rd Street. And look at the phone number. Call 760 Mr. Q's Pet. Bam! Pretty good, right? Huh? The phone number. Oh, my goodness. So, at that store, but we're only going to specialize on 3 different pets because we're going to be distributed for Imperial Valley. We're going to sell dogs. We're going to sell cats. And we're going to sell dolphins. And we're going to have money at the store, all right? So, check this out. So, I'm going to be heading to LA to make to get some merchandise and get some pets ordered, and I'm going to be sending truckloads over here to the valley with all that. So my managers are going to be, let's say, Beto and Gloria. So I'm going to be in LA. I call the store and it's Mr. Q's Pet Shop. And of course that's Gloria. So then I go, Gloria, write this down. I'm going to give you the 2 truckloads that are going, but I'm going to go one at a time. But instead of writing the whole name of each pet to save space and time, from now on I want you to label dogs being X, cats are going to be Y, dolphins will be X squares, and the money, it's just any number I give you. You just write the number. Everybody got it? All right. Yes, Mr. Q. All right, here we go, Gloria. Ready? Here goes the first truckload. I'm going to send you 7 dogs. So she writes 7X plus 5 cats. 5y. 1 dolphin, 1x squared. And I'm going to give you an envelope with $23. There it is. So, okay, I got this, Mr. Q. All right, hold on. Let me give you the next truckload. Ready? Yes. 10 dogs. 3 cats. 3 dolphins. And an envelope with $100. So you're in charge of the money, all right, Gloria? Yeah. Yes, Mr. Q. And then I told her, okay, Gloria, so make sure you put that up on display on the computer, and if people start ordering for other stores, let them know that this is what we got. It's on its way. All right? Put the rest of the people to clean all the displays and the pens, pick up all the poop. All right? Have a good one. Bye. So I hang up. So then later on, I call again. Mr. Q's Pet Shop. Come on. All right, Beto. Hey, write this down. Here goes the truckload of pets. Ready? Yes, Mr. Q. All right. 5 dogs. What does he write? 2 cats. 4 dolphins. And Beto, I don't really trust you. I'm going to send you only $5. There, that's all right. Oh, wait, Beto, before you hang up. Can you read me back what Gloria wrote down and what you wrote down, the complete inventory, to see what we got? What is he going to say here, everyone? 22x plus? 120. What we just did, we added polynomials. Now, this is what I wanted to clarify. Who noticed that we didn't even worry about the exponents on all of these? Everybody see that? Because all these are labels. This is just letting us know that this is different from this, and this is different from this. Everybody understand? So that's a quick intro as to what the polynomials that we're going to be looking at in a little bit. But we just added polynomials right there. Everybody got it? So check this out. More things to clarify. Whenever I give you a polynomial, the number without a variable is called a constant. Look at it. Look at this. Tell your neighbor which ones are the constants. Which ones are the constants? Okay, who said 35 and negative 12? That is correct. Those are my constants because they don't have a variable multiplying it. Everybody with me?
Yeah.
Next.
That's a negative 12?
Okay, look up please. Next, the other like terms, they need to have the exact same variable with the exact same exponent. So look at this. Which ones have the exact same variable with the exact same exponent? Tell them which ones I would combine together. Tell your neighbor, please. Okay? So, look up, please. Look up. So, the ones that I would combine would be 8x squared and negative 5x squared, and 4x with 6x. Does everybody see that? That's what we call combining like terms. Now, how would it look like with work? Look up to the screen. From here, I would say, well, let me move stuff around. 8x squared, negative 5x squared, plus 4x, plus 6x, plus 35, and minus 12. What allowed me to move things around? Tell your neighbor what property I use. Addition. Everyone, commutative property, and now we have addition throughout, so it's of addition. Second property is associative to group, so therefore this becomes 3x squared, this becomes 10x, and this becomes 23, Michael Jordan. Everybody got it? All right. So that's how you combine like terms, and those are the terms that we're going to be using throughout. Now, in regards to the area model, I'm going to come back to it. The area model, I like to introduce using tiles. So look up to the screen first before I have you get yours ready. Look up. From now on, whenever I ask you to get an x squared out, you're going to get one of these blue ones. Well, don't do that right now. Just pay attention. Whenever I ask you to get look up please, whenever I ask you to get an X out, you're going to get a green one. And whenever I ask you to get 1, you're going to get a yellow 1. Everybody with me? So, but what if I ask you to get a negative X squared? Well, you flip this one over and it's red. What if I ask you to get a negative X out? You flip this over as negative. And if I say get a negative 1 out, you flip this one and there's a negative 1 in red. So now, get your tiles out. Get your tiles out of the baggie. There's some in the back.
He's like, I know
Bless you. Okay. Here we go. So, now that you know the names of the tiles, look up. This is what I want you to show me on your desk. Show me x squared plus 5x plus 6 with tiles. X squared plus 5x plus 6. Show me that, please. Bless you. X squared plus 5x plus 6. All right. Let's see if you did as I did. You got a blue squared. You got 5 of the green ones. And how many yellows? 6. There it is. All right. Be nice.
2 of mine only have the red side.
Oh, okay. Yeah, they probably ugly. All right, everybody got that? Next, look up, please. Next, I want you to leave that there. Don't move it. Underneath there, I'm going to give you another set for you to show me. Show me negative 2x squared, negative 3x minus 2. Negative 2x squared minus 3x minus 2. All right. So how many big squares? 2 red ones. So 2 red ones. There they are. How about how many of the rectangles? 3 red ones. Oh, it's too big. 1, 2, 3. And how many of the red small squares? 2. There it is. Are we there so far? Okay. So we have this. So let me show you what you just put in front of you. Look up. What you just put in front of you, you put x squared plus 5x plus 6 plus negative 2x squared minus 3x minus 2. So now we're going to combine like terms but using the tiles. Look up to the screen. Check this out. Look at it. Tell your neighbor if they see what you see. You should see 0 pairs. Talk it over with your neighbor. Tell them which ones are 0 pairs. All right. Let's see what we have left after we added our polynomials. Look up. So, who saw, here goes, who saw that these two become a zero pair? All right? Who saw that these three and these three become a zero pair? All right? And two of these and two of these are zero pair. Therefore, give your neighbor the new polynomial that we have left over. Okay. All right, here we go. So we're left with, who said negative x squared plus 2x plus 4. Everybody see that? And that's how we add or combine polynomials using Algebra Tiles. Okay? But since you're not going to have these tonight, copy this next one without Algebra Tiles. Example 1a. Copy 1a, please. It says, add and subtract 12p cubed plus 11p squared plus 8p cubed. Now, for those of us that have our colored pens, this is why I like to use them. I'm going to start with red. I box the first term. Is there another p cubed? Yes. So for me to not move stuff around, I know that what it will allow me to move stuff around, commutative property, right? So aren't these the same kind? Yes. They're like terms, so I write p cubed. And I focus on the coefficients. 12 plus 8, that is 20. From there I go to blue. I make a triangle. Is there another p squared? No. So I bring this one down, plus 11p squared. Since these are totally different exponents, we cannot combine anymore, and we're done. Yes, sir. I'm sorry? No, we can't because they're totally different. Okay? Yeah, that's home plate. So for tonight, your home plate for tonight is on pages 488 and 489, and it's combining like terms. You're going to focus on the ones that say combining like terms, okay? Yes. Once again, there's tutoring today. If I don't see you, get those those signed progresses back to me by tomorrow. Have a good one. See you guys tomorrow.